welcome to Precalculus Concept 25A, right triangle trig, and we're going to use right triangles to evaluate trig functions. Only 3 boxes today. This is a pretty straightforward lesson only because we've been doing a lot of work based off of right triangles in the unit circle, so this should look pretty easy for you. So let's just start off with an example so you get the idea of what's going on. The example says to find the value for each of the 6 trig functions of theta. So notice that I have a right triangle labeled over here inside this green box, all right? And I know something about this right triangle. If this is the angle that which I'm referring to, which I can call angle A supposedly, and this is the right angle, C, I know that the opposite side has a value of 5, and I know that the adjacent side to the angle has a value of 12. So that only leaves me to figure out what the hypotenuse is. And we all should realize that the biggest advantage of having a right triangle is using the Pythagorean theorem. So we know that a squared plus b squared has to be c squared, where a and b are the sides of the 2 legs of the triangle. So that must be 12 squared plus 5 squared has to be c squared. So that's 144, and 25 makes c squared. That's 169 makes c squared. So then I can take the square root of both sides and get a value of 13. Notice I don't need to worry about the value of negative 13 in this case because it doesn't make sense in the terms of the context of the problem. So now I know the hypotenuse is worth 13. Okay, from here it couldn't get any easier because we have definitions that tell us what the sine of theta is, right? The sine of theta is the ratio of the opposite side to the hypotenuse, so it must be a value of 5/13. The cosine of an angle theta is the ratio of the adjacent side to the hypotenuse, that must be 12/13. The tangent must be is the ratio of the opposite to the adjacent, so it has to be 5/12. Now, in my class, I tell you all to write it like this, like sine, cosine, tangent, and then below that, cotangent, secant, and then cosecant. And the reason I do this is because we know the relationship between sine and cosecant is reciprocal. So therefore, if the sine is 5/13, cosecant must be 13/5. If the cosine is 12/13, since these are reciprocals, it must be 13/12. And finally, cotangent must be 12/5. And boom, we have done the problem. Okay, box 2 is an example. It says find the value for each of the 6 trig functions of theta. Again, I have a right triangle inside this green box that I'm looking at. The only difference here now is that I know the hypotenuse is 3 and the opposite side of my angle is 1. So that leaves me to figure out what the adjacent side is. So again, we'll say x squared plus 1 squared is 3 squared. So x squared must be 9 minus 1 when I move over the other side. So x squared is worth 8, so x is equal to 2 radical 2. If you don't remember how to do that, if I take the square root of 8, that's the square root of 4 times the square root of 2. And the square root of 4 is 2. That's how I got the 2 radical 2. Okay, from here it's pretty straightforward. So sine of theta is the ratio of the opposite to the hypotenuse, so that's a third. Therefore, it must be true that the cosecant of theta is going to be a value of 3. The cosine of theta is going to be 2 radical 2 divided by 3. Therefore, the secant of theta is going to be 3 divided by 2 radical 2. Now, in this case, we need to multiply top and bottom by radical 2 to rationalize our denominator. That's going to give me 3 radical 2 divided by radical 2 times radical 2 is just the number 2. And then times 2 itself is 4. So then I have a 3 rad 2 over 4. The tangent of theta is going to be 1 divided by 2 radical 2. And again, I can't leave it like that, so I'm going to multiply top and bottom by only rad 2. And that would give me let me move this over a little bit here. That would give me a value of radical 2 divided by the number 4. 4 comes from rad 2 times rad 2. That's a value of 2, and then 2 times 2 is 4. Therefore, the cotangent of theta is just the reciprocal of my original problem, so 2 radical 2. So sine is a third, cosine, or cosecant is 3, cosine is 2 rad 2 over 3. Secant is 3 rad 2 over 4, tangent is rad 2 over 4, and cotangent is 2 radical 2. Okay, here's a U-try. I want you to find all 6 trig functions, and then I will ask you for a specific one when the problem is over. So after you push play, you'll be asked a separate question to find a specific one. Okay, good luck.